Here we have section 2.6, which is the algebraic proof. So there's our main ideas and vocab. So just a reminder here of some properties. So the reflexive, symmetric, transitive properties, addition and subtraction rules, and then addition, subtraction, multiplication, division, and then substitution and distributing, which hopefully you are familiar with already. So an example of this looks like this guy. So solve that equation, justify each step. So that means you're going to need pretty much two columns, one for your math, and one for the work. So you always start with your given statement. So to solve this, I have to multiply that 3 through. So that is the distributing. Add the 6 to both sides, so the addition, and then divide by 3. Division. So that's what it looks like. So you have one column for your work, one column for your reasons. So that is kind of actually an example of a two-column proof for a formal proof. So you have one column for the statements, one column for the reasons. So similar thing, two-column proof to show that if 3 times x minus 5/3 equals 1, then x is equal to 2. So you actually start the same way, except this time you know what the answer is. So that's given. So once again, distributing. Addition, so you add the 5 across. And then division, divided both sides by the 3. So that's what a two-column proof looks like. So statements and reasons. Just a couple reminders here. So in this case, these are rules for segments. So segments can be equal to each other, as can angles. Symmetric property and transitive properties are also true for angles. Angles and. All right, for example 3, gives you these statements here. So AB is congruent to CD, CD is congruent to F. Which of the following is a valid conclusion? So AB equals CD and CD equal to EF. This is valid. That's the definition of things being congruent. If things that are congruent, they're also equal. AB is congruent to EF. This is also valid. That's the transitive property. AB is congruent to CD and CD is congruent to EF. And then 3 is also valid because if 2 is valid, so is 3. Things that are congruent are also equal to each other. Okay, and the last one here, on a clock, an angle formed by the hands at 2 o'clock is a 60-degree angle. So I'm going to say the measure of angle 2 is equal to 60. And the measure angle 2 is congruent. Angle 2 is congruent to the angle at 10. That's really bad. We'll start that over. Angle 2 is congruent to the angle formed at 10 o'clock. Prove that the angle formed at 10 is a 60-degree angle. So we'll work down here. So measure angle 2 is equal to 60. That is given. Angle 2 is congruent to angle 10, also given. Angle 2 is equal to angle 10. That's the definition of congruent. And if angle 2 is 10 and 2 is 60, these should have measures in front of them, I can say that 60 is equal to measure angle 10. That's by substitution. Prove that measure angle 10 is equal to 60. This is the symmetric property. All I did was reverse. Now you have to be careful because at once measure 10 is equal to 60. So that is your proof.